All right, here we go. In this video, example 2, we're going to test the extreme value theorem to see, excuse me, if we can apply it. So in all of these, we're going to answer these 4 questions. In the first graph, is the function continuous on the closed interval? Well, from -3 to 4, it is closed, right? And it is continuous. So we're going to say yes. Therefore, can the extreme value theorem be applied? Yes, because it met both of those criteria, right? It is continuous and it's continuous on a closed interval. What about the middle graph? Is the function continuous on the closed interval? Well, it is continuous within the interval, but it's not a closed interval, so we're going to say no. Can the extreme value theorem be applied? No. And then finally, is the function f of x continuous on the closed interval? Yes. And can it be applied? Yes. Okay. So now I'm going to look at the actual graph and look to see, does it have a maximum or a minimum? Well, in the first graph, the highest point would be here and the lowest point would be here. So yes, both an absolute, max, and min. Let me do it, max and minimum. Okay, when I look at the second one, does it have a max and a min? Well, the max should be up here, except it's an open circle. That means it doesn't exist. However, there is a minimum, so I'm going to say there is an absolute minimum. By the way, in the next statement, we'll write out how to identify where that absolute minimum is. And then in the last one, is there an absolute maximum? There is a highest point. This is the highest point. It occurs at 2 spots. And then this is the lowest point. So both absolute max and min. So again, just because the extreme value theorem is not satisfied, like the middle term, like the middle graph, doesn't mean that there is no absolute max or min. It just means that we're not guaranteed the max and min. In both the first and the third, because the extreme value theorem was met because of the conditions, I was guaranteed that I was going to have both. In the middle one, it wasn't guaranteed, but that doesn't mean that there aren't any. That means I'm just not guaranteed. There could be, but I don't know. And so therefore, I'm going to write the statement for the absolute extrema. Okay? So there's an absolute max of, what is the absolute maximum? The absolute maximum is 3. That's the y value. That's the function value at x equals -1. And the absolute min, I can also write absolute min is -1 at x equals -3. But again, we want you to excuse me, understand, whenever we're looking for the absolute max, we're actually looking for the y value. This tells me where it occurs, right? And so when I jump to the last one, the absolute max is 4. There's only one absolute maximum, but it happens at x equals -3 and x equals +3. And the absolute min is 1, and that happens at x equals 1. So the statement tells the reader, that you understand that the absolute maximum is the y value, and it occurs at 2x coordinates, 2x values. The absolute min is this y value, that's the lowest y value on the graph, and it occurs at x equals 1. And then for the middle one, there's an absolute min, and it is -3 at x equals -1. That's how you'll write out the answer. When we come back in the next video, we're going to look at some equations. And at the end, this is the statement that we'll be writing to identify what exactly it is we found.